In this video, we're going to look at the problems in the 2.1 slides. The first problem is this: we're asked to give a complete listing of all the elements in each of these sets. So here are the, here are the sets that we're asked to define in terms of their elements. We start with the counting numbers between 8 and 13. Now, when we say between, that does not include 8 and 13 themselves. So the counting numbers between 8 and 13 are 9, 10, 11, and 12. And to show that that's a set, we did put the brackets like that. Next, the set that includes 5, 6, 7, and so on through 13 is equal to the set of 5, 6, 7, 8, 9, 10, 11, 12, and 13. Finally, we're asked about the set of x, where x is a counting number between 4 and 5, and that is equal to the empty set. There are no elements, there are no counting numbers between 4 and 5 because the counting numbers are the positive integers. Moving on. Next, we're asked to determine if these statements are true or false at the bottom here. This is on page 7. So here are our statements. The first is that 4 is a member of the set 1, 2, 5, 8, 13. This is false, since we do not see 4 in this set. Next, we are asked, is it true or false that 0 is a member of the set 0, 1, 2, 3? That is true, because we can see the 0 right there. And finally, we're asked if 1/6 is not a member of the set 1/3, 1/4, 1/5, and that is also true because we can see that 1/6 is not one of the elements in that set. Next, we're asked to find the cardinal numbers for these sets here at the bottom on page 9. We start with the set K, which is equal to the set of 3, 9, 27, and 81. The cardinal number of K, or n of K, is 4. There are 4 elements in that set: 3, 9, 27, 81. Set M is the set that includes only 0, so the cardinal number of M is 1. There is only 1 element in that set. B is the set that contains 1, 1, 2, 3, and 2. But remember that we only count elements in a set once, even if they appear multiple times. So 1, 2, and 3 are the only members of this set, and the cardinal number is 3. R is the set that includes the numbers 7, 8, and so on through 15 and 16. That means that we've got 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, which is 10 elements. And finally, we've got the empty set, which we define as the set that has no elements. So the cardinal number of the empty set is 0. Next, we're asked to designate all odd counting numbers by the 3 common methods of set notation. Remember that these are an infinite set, so we have to figure out a way to determine this. So first, we need to set it up as a text statement, and we can just say that is the set of all odd counting numbers. For a listing, we can write the set 1, 3, 5, 7, and we could have stopped after 5 really, and then we just put and so on. Put our ellipsis there, because that can go on forever. Finally, in set notation, we can say the set of 2n minus 1, where n is a counting number. 2n minus 1 is equal to 2 times some number minus 1. 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3, and so on. It gives us exactly the same set. Next, we are asked to are the sets -4, 3, 2, 5, and -4, 0, 3, 2, 5 equal sets, and we're also asked some more true or false questions. So we'll start with this. Are -4, 3, 2, 5 and -4, 0, 3, 2, 5 equal sets? No, they are not, because 0 is a unique element in the second set that is not in the first. Finally, our true or false questions. We're asked, is it true or false that the set that includes only 3 is equal to the set of x such that x is a counting number between 1 and 5? That is a 1, not a 3. So let's consider the counting numbers between 3 and 5, between 1 and 5, I'm sorry. That would be 2, 3, and 4, but that is not equal to the set of just 3, so this is false. The set of x such that x is a negative counting number equal to the set of y such that y is a number that is both rational and irrational. Well, this negative counting numbers don't exist. All counting numbers are positive. Therefore, this is the empty set. And y is a number that is both rational and irrational. Rational numbers are not irrational and irrational numbers are not rational. So this is also the empty set. So this is true. Finally, we've got the set of 0, 0, 1, 1, and 2, 4. And we're asked, is this equal to the set of x, y, where x is a natural number less than 3 and y is equal to x squared? And this is false because 0 is not a natural number. It's a whole number. That's it for this video. If you have any questions, please get in touch.